Hello students. Today I will discuss about the importance of transport in economic geography. After this session, you will be able to understand what does transportation mean in terms of geography, transportation and its purpose, the role of transport in economic geography, significance of economic geography, concept of transport geography. Transportation is the process of spatially connecting a device demand. Distance is a relative concept that takes into account factors such as space, time and effort. Space is a generator, a support and a constraint of mobility, all at the same time. Transportation is the means by which derived demand is spatially connected. Distance is a relative concept that takes into account factors such as space, time and effort. Space serves as a generator, a support and a constraint for mobility, all at same time. That is what I explained you. Space and time can converge or diverge in their relationship. Transportation must consume space in order to overcome geography. Transportation's singular purpose is to transcend space, which is shaped by a variety of human and physical constraints, including distance, time, administrative divisions, and topography. When they act in concert, they impart friction on any movement, which is commonly referred to as distance friction, or in other words, I can say friction of space. Transportation in an ideal world would be effortless in terms of cost and time, with unlimited capacity and spatial reach. Geographical location would be irrelevant in such circumstances. However, geography can be a significant constraint on transportation in the real world, as it creates a space for time and money and can be circumscribed only partially. The extent to which this is accomplished has a cost associated with it that varies significantly depending on factors such as the length of the trip, the capacity of modes and infrastructure, and the nature of the cargo being transported. Transportation geography can be understood through the application of 8 fundamental principles. What are these principles? First is, transportation is the mean by which derived demand is spatially connected. Second is, distance is relative concept that takes into account factors such as space, time and effort. Third is, space serves as a generator, a supporter and a constraint for mobility, all at the same time. Fourth is, space and time can converge or diverge in their relationship. A location can be central, generating and attracting traffic, or it can be intermediary element through which traffic passes. The sixth one is, transportation must consume space in order to overcome geography. Seventh is that transportation aspires to be more massified but is constrained by automation. Eighth is related to velocity. Velocity is a managerial, modal and intermodal endeavor. These principles emphasize that without transportation there would be no geography, and vice versa. Thus, transportation objective is to transform the geographical characteristic of freight, passenger or information from their origin to the destination, while conferring added value on them in the process. There are significant operational distinctions between mode of transport, most notably between passengers and freight, which are frequently operated separately. The ease with which this can be accomplished varies considerably and is frequently referred to as mobility. Now let me explain you mobility, because it is very important to understand mobility when you are understanding transportation. The ease with which a passenger or a unit of freight can be moved, that is called mobility. It is related to both the cost of transportation and the characteristic of the cargo being transported. Fragility, perishable, prices, these are other factors associated with this. Apart from that, political factors such as laws, regulations, border and tariff can also affect mobility. When mobility is high, activities are not as constrained by distance as they are when mobility is low. Transportation is not a science in the traditional sense, but rather a field of application that borrows concepts and methods from a variety of disciplines. Transportation's specific purpose is to meet a demand for mobility, as transportation cannot exist without moving passengers, freight and information. Otherwise, it is pointless. This is because transportation is primarily the result of derived demand. It occurs as a result of other activities. Distance, a critical characteristic of transportation, can be expressed in variety of ways, ranging from the simple distance like a straight line connecting two points, to what is referred to as logistic distance, the complete set of tasks required to overcome the distance. Thus, any movement must take into account its geographical context, which is intimately connected with spatial flows and their pattern. Flow is a concept comprised of four major components. One is geographical. Each flow has a beginning and an end, and thus a degree of separation. Flows with a large degree of separation are typically more constrained than flows with a small degree of separation. Second factor is physical. Each flow has distinct physical characteristics in terms of load, unit that can be carried, and the conditions under which they can be carried. Flows can be atomized, smallest load unit, or massified depending on the mode of the transportation, moving load unit in batches. Another factor is transactional. Each flow must be negotiated with providers of transportation services, such as booking a container ship slot or an airline seat. A flow is frequently associated with financial transaction between a provider of transportation services and a user. Another factor is distribution. Flows are sequenced with more complex involving multiple modes and terminals. Numerous transportation flows are scheduled and routed in order to reduce costs of increased efficiency, frequently via intermediary locations. The role of transportation geography is to comprehend the geographical relationship that transportation network generate. This can lead to a number of transportation policies in terms of the relationships between access, accessibility, distance and time. A greater knowledge of spatial linkages is required to aid commercial and governmental actors involved in transportation in addressing important transportation issues such as capacity, constraints, system transfer, mobility, reliability, and system integration. There are three key geographical concerns for transportation system. The first is the location. Because all activities take place, each location has a unique characteristic that influence supply and demand for resources, goods, services and labor. The type, origin, destination, distance and even the possibility of a movement will all be determined by the place. A metropolis, for example, creates job in variety of industries which also consuming resources. Another important issue is complementarity. You should understand this complementarity. Some regions have an abundance of labor, resources, parts of finished items, while others have a shortage. Movements between location with supply or a surplus and a location with needs are the only way to achieve balance. A complementarity is generated, for example, between a store supply of goods and its client demand for goods. Another important aspect is scale. Complementarity generates movement at various scales depending on the nature of the activity. Scale depicts the development of transportation system over local, regional and global geographies. For example, most home to work trips are on a local or regional scale, whereas a multinational corporation's distribution network is likely to span several continents. As a result, transportation system consume land and support relationship between areas on a global scale. In this regard, transport geography offers a multidisciplinary view on the complexities of transportation and how place, both facilitates and inhibits mobility. Transportation importance is increasing, especially in light of the following contemporary trend. The first one is demand expansion. The second half of the 20th century saw a significant increase in transportation demand for both individual on passenger basis and freight mobility. The increase is due to the increased movement of passengers and freight, but also to the longer distance cover. Second aspect is cost saving. Even though several modes of transportation such as ships and planes are expensive to own and operate, the cost per unit transported has decreased significantly over the last decades. This is especially true for transportation services that face intense competition. That has been reduced. Reduced transportation cost enabled greater distance to be covered and the comparative advantage of a space to be further exploited. As a result of the lower cost, the transportation sector share of the economy has remained relatively stable over time. Transportation services are being used more frequently, but their costs are decreasing. The third important factor is the infrastructure expansion. Both of the preceding trends have increased both quantitatively and qualitatively the demand for transportation infrastructure. How? Road, rail, harbor, airports, telecommunication infrastructure and pipelines have all expanded significantly in recent years to serve new areas and to add capacity to existing network. Thus, transportation infrastructure accounts for a sizable portion of land use. Faced with these contemporary trends, a significant portion of the economy's spatial differentiation is determined by the location and distribution of resources such as raw material, capital, people and information. For example, transportation routes are established to distribute resources between areas of abundance and areas of scarcity, but only if costs outweigh the benefits. As a result, transportation plays a critical role in global, national and regional economies. It is a strategic infrastructure that is so ingrained in the socio-economic lives of individuals, institutions and corporations that it is frequently imperceptible to consumer but integral to all economic and social functions. As I explained earlier also, that rather than being a science, transportation is a field of inquiry and application. Transportation studies, regardless of their discipline affiliation, share two characteristics: a heavy reliance on empirical data and on extensive use of data analytical techniques ranging from simple descriptive measures to more complex modeling structure. Transport geography in some ways distinguishes itself from many other branches of human geography due to nature and purpose of its quantitative analysis. Transport geography was a driving force behind the quantitative revolution that reshaped geography in 1960s through the application of inferential statistical abstract models and new theories. While this perspective added much needed rigor to the discussion, it also favored a separation of empirical and theoretical approaches. As with economies, the quantitative revolution ushered in the mechanistic perspective in which concordance with reality took a backseat. Realities were reshaped to fit models, even though contemporary transport geography takes a more diverse approach. The quantitative dimensions is critical to the discipline, as transportation research is expected to be backed up by data and methodological approaches. The main objective of these methods is to enhance the mobility by identifying spatial limitations. These limitations may be capacity, expanse, time, environmental, but are more frequently combined. Consequently, relevant policies and strategies can be identified and certain scenario of their possible consequences can be provided. The methods used in transport geography are variously classified into whether quality or quantitative. Whether infrastructure, example terminal or flows are involved, whether interpolation or extrapolation is provided, whether description, explanation, or optimization is provided by the technique, the nature of the assumptions or the complexity of the calculations depends on the level of data aggregation. Space and time processes cannot be considered separately, as it is very important to study it in an integrated way, as in the case of geographies. They can be divided into methods of transport and multidisciplinary methods by a basic taxonomy. Now, second approach is the first group of methods relate to transport students directly, since the majority of these methods originate from the planning of transports. The methods used mainly in the geographical area of transport include, the first one is network analysis. Also it is called as a graph theory. Used in research on forms and structure of transport network, especially how they change in time. A range of mathematical instrument has been offered by network science in transport geography. Network analysis can, for example, be used to evaluate the development of hub and speaker airline services configuration. In the study of land use, transportation interactions, transport geographers also play a key role. The development of numerical models has grown increasingly complex over time. Flow and localization models that can be used for the purpose of defining such things as school, districts, limits, or place for a new retail outlet are also interest to transport geography. These techniques are procedures for optimization rather than methods to describe or understand existing transport system. The geography of transport enables empirical representation of different dimensions of transport system. Moreover, in transport studies, different methods of general use can readily be applied in transport geography. First of all, a variety of techniques are applied to model urban transport, which aims to understand and predict the spatial pattern of urban transport. Second is, traffic surveys are used to collect empirical information, for example, of movements and frequencies. Now, the third approach in transportation is multidisciplinary approach. These includes all methods that have not been developed specifically for transport studies, but that are easy to use for its analysis. They are labeled as multidisciplinary as they can be applied to variety of problems regardless of the discipline. Firstly, there are methods which are key to geography but not limited to study of transport system. You may be thinking, what type of methods are this? The most obvious example of geographical engineering is cartography. As a geography student, you are well aware of cartographic techniques. Indeed, in the analysis of transport system, various types of maps including land use maps, transport infrastructure, depictions, isolated transit cost map, or moving activity pattern schemes are used. A set of tools for storing, retrieved analysis and showcased spatial data from the real world provide geographical information system, that is GIS, an outgrowth of digital cartooning. In large scale, transport planning and technology applications such as GIS technology has been used. However, GIS is most often used by prescription to address small scale issues such as tracking the optimum routes for buses or transportation trucks and emergency vehicles. There are also different statistics which geographers have developed or modified to describe urban economic system. So, the coefficient Gini and concentration and specialization indexes are its example. Secondly, different methods including transport analysis are employed in many different applications. They stress that transport analysts are not confined to these transport methods, but to whatever is relevant to a particular problem. Many methods originally developed for other issues are in fact widely used in transport studies. Some methods such as questionnaire or interview are used to collect primary data, while other methods are used to analyze it. Some of the analytical techniques are easy to use and interpret. For example, disperse gram or curve of the distance decay, and tables, for example, matrix of source and destination. These are two examples. Other are more complex, such as t-test or correlation, variation, regression, or chi-square, inferential statistical. In nutshell, I can say that transport studies are increasingly focused on economic impact and issues of public policy. They rely more on qualitative information, including policy statements, rules and regulations and time. Different type of effects, including economic, for example, community developments, social, for example, access to service, environmental, for example, air or water pollution, and health are considered. These issues are related to broad areas of environmental assessment, risk evaluation, and policy analysis. So, I hope that after this discussion, now you may understand that the role of transport geography is to understand the spatial relations that are produced by transport systems. This can give rise to several policies about transportation in terms of respective relations between access, accessibility, distance, and time. A better understanding of a spatial relation is essential to assist private and public actors involved in transportation, mitigation key transport problems such as capacity limit, transfer between different systems, the reliability of mobility, and the integration of transport systems. These are three basic geographical considerations relevant to transport systems.